So I think the the break is up, but it's time to continue. Alina, I think you're on the line already because I see your slides already showing up. So feel free to start your presentation.
Hello, I hope you can hear me and you see my slides.
Yes, we do.
Okay, so today we are going to talk about Intel distribution for GDB. And actually, we are going to explore some debug features in three main directions. It's DBC++, as this is our new feature, Fortran, and OpenMP offload. So this is only, offload is supported only for C++ yet. And well, I'm going to cover as much as possible in the next 30 minutes. And actually, we won't spend much time on slides. So it will be more about demo. So yeah, but let's review system requirements first because it's important. You see that we are not going to actually to stop here for a while. And so, well, debugger supports Windows 10, Windows 11, Microsoft Visual Studio, including 2022. But, well, please note that the support of Visual Studio 2017 is deprecated and will be removed in some of the future releases. What is more important is hardware supported because we support Gen 9 and Iris graphics, and we support Core, Xeon scalable CPUs, and FPGA as emulation device only. On Linux, you see that hardware is the same. Language support is the same as well. And we support Eclipse and Visual Studio Code as IDEs. And I strongly recommend you to use these links to release notes, to system requirements, and check for each release because they are really, we really often change them. So stay tuned. And we are going to start from DPC++ demo. So if you are going to do it offline, I would recommend you to follow Get Started guide to configure the debugger because it is not always obvious. Just because you need debug companion driver and it is not installed with one API toolkit because it requires root privileges. So you need to install it after the base kit. And we also recommend you running array transform sample to make sure that debugger is configured correctly. And for those who also going to do it offline, we are going to work today with Jacobi sample, and you can clone it from one API samples, navigate tools, application debugger, and find Jacobi folder. And also don't forget to source one API variables before for running the debugger. So Jacobi sample is a DPC++ application that solves linear system of equations. We are multiplying a matrix A by vector X equals B, and X is solution vector. Vector B is set in the way that all components of the solution vector X are 1. So, however, Jacobi bugged. We prepared two versions. One is Jacobi bugged. It returns an incorrect result for vector X. So you can find all these bugs and fix them one by one. And also, obviously, we prepared a fixed version so you can refer to it if in case of any questions. And yeah, this is short notes for you if you want to do it offline. And I'm going to show you a screen. And well, So let's see. There are two files, is Jacobi bugged and Jacobi fixed CPP. And there are 3 bugs. 2 of them you need to fix on CPU, and the third one is on GPU. I recommend to follow the order of bugs. First fix bug 1, then bug 2, and then switch to GPU. We will fix only one bug. I have already prepared the environment, but I remind you again that you need to source one API variables first. Yeah, so environment is ready. We are going to build the sample. Let's first, yeah, so we are going to build the sample. I need Jacobi bugged CPP, and note that we need to build it with G option and with O0 option. G includes debug information to the executable, and O0 disables optimizations. If you try to debug the executable compiled with O2 or with any other optimizations enabled, then you will possibly get optimized out message in the debugger when you try to see variables, local variables. This happens because optimization changes everything in your code, so including the line order, line numbers. That's why we strongly recommend disable optimizations for debugging. Okay, so building the code. Yeah, okay, so, and let's select target device as a CPU and run it like this. So we need Jacobi bugged, right, CPU. So yeah, you see there are some hints for each bug, and we need to find why some components of XK are not close to 1. To examine variables and before starting the debugging, we need to check sources. Just because, for example, if we are going to stop on a breakpoint, we need to find a line or to find where we are going to start. And so let's open the source file and check where XK is computed. Yeah. So from the very beginning, this include blocks, structure. Yeah, main computation. Yeah, we have accessor here. It's accessor XK, which belongs to buffer XK. So I guess the main computation happens here. XK computation happens in main computation function. And this is our DPC++ kernel. And yeah, this is here. And since since accessors are an abstraction for arrays, then probably it means that something happens with array bounds. Because you see, we are working with indices here, and subtraction is dangerous for some I values. And so we are going to start with the line 77. Let's run the debugger and stop at this line. I'm going to run the debugger like this. It's GDB1 API in command line, args, and pass my executable with command line arguments. There is an alternative way how you can run it. It's just your GDB1 API and your executable, but I personally prefer pass command line arguments like this. So you can pass command line arguments to the run command in the debugger, but I just prefer to do it this way. So running the debugger, and the main thing that we can see here is reading symbols from Jacobi backtick. It means that debugging symbols detected and loaded, and just because we added G option to our compiler line. And now we can start debugging. We decided to start with line 77, so I'm setting a breakpoint and just running it here. Yeah, so you see, I'm going to scroll it up, and you see that Intel GDB server started for process. It means that everything is going fine. So debugger detected your executable, and we stopped here. This is our breakpoint on line 77. We can print I value. And at this specific thread, it is correct. So there is nothing dangerous happens. We can switch to another thread and print it again and see that, yeah, it is also correct. And to stop, to avoid switching these threads one by one, I would suggest you using a conditional breakpoint. I'm going to remove my first breakpoint just to avoid some issues, and let's set a breakpoint 77 with a condition. It is really easy. I just need to run if I less than, for example, less than 1. It means that we are out of bounds. It means that we are trying to reach a negative index of the array. Let's break and run again. Yes, I'm going to run from the very beginning. Yeah, so this is one thread hits this breakpoint. It means that, yeah, we are right. And that our general expectation is right. So let's quit the debugger and see sources again. Yeah, so to fix this issue, it's quite easy. We need to add some conditions here, something like this. And we need to do it for each line. And thus we solve the first bug. For each, and here with addition, it needs to be less than n minus 1, and n minus 2, right? So yeah, I'm going to save it. And recompile. Oh yeah, I see. I just missed minus. So yeah, we are recompiling, and yeah, so I'm going to run it and see that, yeah, we are ready to fix bug 2. But actually, what I'm going to show you is GPU debugging. So I suggest you continue playing with this application offline, fix the second bug, and move to the GPU. And I'm going to work with fixed version and explore some debug capabilities. Yeah, so I'm going to build Jacobi fixed and run it under the debugger. With the GPU command line argument. Right, yeah, the same. We see that reading symbols, it's okay. And let's set a breakpoint. Can be also line 77. Yeah, and we are going to run. Yeah, you see that we hit a breakpoint here, and thread syntax a bit different. So firstly, we need to check the device where we are. Let's make sure that we are on GPU. Info inferiors command gives us this information. You see there is our CPU process, and this is our GPU device. And also you can see list of available threads. You see this syntax. This is thread ID and CMD lane ID. I could run it on CPU and show you the difference. Oh yeah, it's better to run it like this. It's break 77 and run again. This is a CPU only. So you see that there is only one device here, one process here, and there are so many threads here, and there is a different threads naming. So you see the difference. And I'm going to go back to the GPU, with the debugger, and run it again with GPU, and see some other important features that are useful for GPU debugging. It's running, and well, we are going to play with threads more. Firstly, you can switch between threads using the command thread, and we are on thread 2.1 here, so we are going to switch, for example, to thread 3.1 and CMD lane 0. Oh yeah, okay. So maybe 2.2. Let's play. Yeah. So this is another thread. We switch to it. We can inspect local variables for this thread using info locals command, right? Also, you can investigate all active CMD lanes at once for this thread using thread apply. We are 2.2 and asterisk here, print, for example, let's try print I, right? You see well, all variable values of I for thread 2.2 for each CMD lane. Also, you can apply in the same manner for to all active CMD lanes of all threads. It will be like this: thread apply all lanes and print I as well. So you see how many, you see each thread ID and CMD lane. So you can check it in the same time. And also registers are available. It's enough just to type info-rec and check all the GPU registers. You see there are registers starting from R0 to R46 and even more, but I'm going to quit because there are so many info on the screen. So okay, two more features that might help you is also there is a disassemble view for your kernel. Oh yeah, this. Ah yeah, disassemble. Yeah. So we can scroll it down or yeah, or move it. Also, you can before before stepping to the next line, I would recommend you to prevent to run this command to prevent you from intervention of other threads, because you see that I'm going to press continue. I will hit another thread and another one and another one. If you are going to continue execution, I need set schedule locking step command. And now, yes, oh, I can continue without any problems. So, okay, should be like this. Okay. So we are going back to slides. And the next is debugging OpenMP offload. It's a very short point. I'm going to just go back and show you a couple of important points. Firstly, you need to build your. This is it's a very simple code. It's just matrix multiplication, and we are going to build it like this. We are passing FI OpenMP option, F OpenMP targets to build my OpenMP offload code, and firstly, let's disable optimizations for our offloading code. For this, you need to export libopenmp compilation options. I disable here both for OpenCL and for level 0, just because just to avoid just not to forget to disable it if I'm going to change my backend. And also, libopenmp target offload mandatory means that I'm going to offload my code, which is my offloading region. I'm going to offload it to GPU. There are some alternatives, and tomorrow we are going to talk more about offload. But yeah, so let's firstly, before starting the debugging, let's take a look at this sample. This is C++ code, and the function compute contains a float region. And what we actually need here is line number. This is an offload region for loops, and yeah, this is line 31, which is inside the offload region. So I'm going to run the debugger, break line 31, and run it. Yeah, we successfully hit the breakpoint inside the offload region. You see that we are on a device now, and oh yeah, and you see that threads a bit differ from what we've seen for SQL. So that's all for debugging, but I'm going to remind you that there are some options that helps you to debug OpenMP offload without the debugger. You need libopenmp target debug option to get some this option is used here, libopenmp target debug option to get some runtime debug information. So you see that it contains so many information about runtime, what's going on with your variables, memory operations, and so on. So I would recommend you to use this all these tools together, or it totally depends on your task. And the last one, the last point I plan to show you is function expression evaluation for Fortran. Well, also I need to emphasize that debugger supports OpenMP offload only for C++. It's not supported for Fortran yet. And this feature and Fortran expression evaluator is supported for Fortran only. So it's not supported for C++. And what you need to do to use it is just, well, this is also a very simple Fortran code. I've set a breakpoint and I'm going to start a debugging, right? And well, I need to push a debug windows and immediate window. This is here. So since I started on this point, on this line, I can check it like this, the value of AK, and which is more important is that I can compute expressions like this and see the values right during the debug session. So I would recommend you playing with this more offline if you are interested in. But my yeah, this is to remind you for your offline. And a couple of words about other debug capabilities. What else you can do without the debugger or with the debugger? This is a short, a couple of notes about it. So I would recommend you playing with SQLPI trace variable if you are going to debug SQL plugins and see if there is something wrong with SQL runtime. Also, there are two tools for debugging GPU backends. It's ZETracer for level 0 backend and intercept layer for OpenCL. And also I also remind about libopenmp target debug for debugging OpenMP offload. And what else? I collected useful links for you. Some basic topics like release notes, system requirements, documentation, how to get started, and run samples. And there are two advanced topics. The first one is our OneAPI programming guide containing some tips and tricks how to debug OneAPI applications. And also a separate topic, how to get started open and pure float. So if you are not familiar with this yet. So that's all. Any questions?